Okay, now we're gonna have the last talk of the day of our session from plants and microbes, and we're gonna have Ashish Nerlikar. Sorry if I mispronounced your name. Talking a little bit more about savannas. So now it's your turn, Ashish. Thank you.
Uh, Hi, just a sec. Yeah. Um, okay. So, hi, I'm Ashish, and I'm going to present a talk which will tell you a story about the ecological history of a tropical savanna in India. Okay. Uh, so, the dominant narrative of the past century or so has about tropical grassy biomes, which includes grasslands, savannas, and open canopy woodlands, has been that they are pretty recent in origin. Uh, and that means that they're pretty much formed as a result of human induced deforestation. Uh, so because of this, they have been widely misinterpreted as arrested successional stages of a forested ecosystem, and more so for the Indian savannas, which have been long assumed to be a product of human-induced deforestation. So this is the key background or the key problem on which I'll be basing my study. Uh, so with that, my question for today's talk, which I'll be addressing, is: are the savannas in Pune city, India, anthropogenic in origin or not? So these are my hypotheses. So if they are actually anthropogenic in origin, we would expect something like this on the top panel. So we would expect that uh, savannas would have formed after a forest configuration, which means that at some historical state or point in time, there would be a forested configuration with closed canopy tree species without a grassy continuous understory layer, being replaced by a savanna configuration with scattered trees and a continuous grassy layer in the understory because of anthropogenic degradation. But if these savannas are actually not anthropogenic in origin, which means if they're ancient, we would expect to find this savanna configuration no matter how far back in time we go. So the same throughout. So these are the two hypotheses we'll test. So I'm sure that at least some of you were surprised to hear that the savannas in India. So here's a map of where they are. So the shades in blue are savannas in Africa and Asia, and this triangular portion in India over here is the savannas in India, and this is Pune city, which will be the study location. Uh, so in order to test these hypotheses, I'll be using data sources from these four uh, themes, and I'll be summarizing them to find out, so to try and test these hypotheses. So this is how a part of the hills looks today, with scattered acacia trees and a grassy continuous layer. This is time zero, so as of now. Uh, what we'll do is in the next slides, we'll try and go back in time and see if we find a forest ecosystem sometime back. So I present my first line of evidence, which is historical records. And this is a picture of the same hill which you saw in the earlier slide, taken about 100 years back from today. And you see that there's clearly no forest 100 years back. So it's the same savanna configuration. Uh, let's go back a century further back. And this is a painting done somewhere around 200 years before present, and it shows that in the bottomlands where you have civilization, you have these trees which are clearly planted, but the uplands, which are the hills, these clearly represent open ecosystems with shrubby and grassy layer. So clearly no forest. We can go back still a bit further uh, to find that this painting again shows a clear savanna configuration, so no forest. The limitation for historical records is they do not take us back beyond a couple of centuries. So we need another line of evidence to look at that, which is paleoecological records. So this is the second line of evidence, and this is essentially paleo or fossil pollen records from a place in central India, which is biogeographically similar to the Pune city savanna landscape. So, uh, in the left panel over here, you can see the y-axis represents years before present. So 0 years, which is today, 1,000 is 1,000 years before present, 8,000 years before present, so on. So from top to bottom, you go back in time. Uh, this is a panel which represents the abundance of pollen grain for these three functional types of species. So the first is moist species, which are essentially forest species. The second is the savanna species, and third is the scrub species. So the agricultural expansion in this region in the western part of India started only since 4,000 years before present, which would have been a major source for forest or land clearance. So 4,000 years is this line over here. So if our narrative was true, we would expect a savanna signature from 4,000 years to today, which is this part of the graph. Sorry. So we would expect a savanna signature from 4,000 years to today, which is the top part of the graph, but not so in the bottom part. So we would not expect to find savannas right in this region. But you can see clearly that savannas are present throughout this entire spectrum, and they actually spike at around 9,000 years before today. Uh, this panel on the right, you can ignore whatever's written in there and just focus on the colors. So the reds indicate drier times in the subcontinent's history, whereas the blues represent wetter times in the subcontinent's history. So you can see that wet zones correspond well with the abundance of moist species, dry times correspond well with the abundance of scrub species. But irrespective of all of this, the savanna element dominates up till 9,000 years. And this is uh, where our pollen records can take us. But my next line of evidence takes us back millions of years. So this is a phylogeny of a group of lizards called the fan-throated lizards, which are found on these hills. And the x-axis over here is million years before today. So this is 0 million years, 10 million years, so on. And you go back in time over here, and this graph represents the diversification pattern of this group. Uh, you can see that so before that, the green part indicates wet regions in the Indian subcontinent's history, and the transition to ochre zones means drier parts or aridification. Uh, so it's very clear that this Sitana group has diversified somewhere around 5 to 10 million years, consistent with uh, the aridification of the Indian subcontinent. So the presence of such species is another indication of an open landscape. So these are two more examples of another group which shows a very similar pattern, uh, presence of species which diversified in response to the late Miocene aridification. And the last line of evidence which I'll present is the characteristics of the present or extant biodiversity. So as of now, there are quite a few endemic plants like this dwarf jatropha with tuberous underground parts, which are a clear adaptation for frequent fires. C4 grasses like this endemic Lophopogon, which have evolved uh, way back uh, around 4 million years ago, and a range of other endemic diversity, especially reptiles. And people are still documenting more endemics from this region. So if this was a forested region before and then a savanna, we would expect to find forest generalist species instead of savanna endemics. So that's it. And with this, I would conclude about my hypothesis that this region is indeed antique, which means that these savannas in Pune city are actually really, really ancient. Uh, so you can see in this lower panel that they were clearly as they are today with the savanna configuration since at least 4 million years and have been maintained by regular surface fires and grazing throughout time. Uh, so imagining such ecological histories is pretty common around the world. So people have imagined such forested histories in many parts, including areas in Africa where people actually thought that open spaces created around some villages were anthropogenic, and then these notions were also dismissed recently. So what does these imagined histories mean for our land management today? So in this image, you can see trenches dug for planting trees in this region with the aim of reforesting the region. But reforestation would mean that there was a forest before, and now we know that there clearly wasn't a forest. So this clearly can be termed as afforestation. And research is pretty clear that planting trees in regions where they do not belong does more harm than good to the biodiversity and ecosystems, which ecosystem services that these places provide. Uh, so with that, I'd like to leave you guys with a single important message, which is savannas like forests can also be ancient, and that appreciating their antiquity is critical in the light of global change. I'd like to thank uh, some libraries, my funding agencies, and friends and experts for this, and I'm happy to take questions.
Thank you, Ashish. Now we're gonna have time for questions. As I told you before, you can unmute yourself or make the questions on the chat.
Hey Ashish,
Hi.
I just have a doubt. So, do you think the same trend would be there in all savannas across the world, or like, do you think the difference in the trend would be between the city, the urban savannas, and the savannas which are like a bit less disturbed?
Right. So that's a good question. So the thing is, a lot of socio-ecological things also matter because these are savannas within the cities. But if you talk of the landscape in general, this clearly applies to a lot of other tropical savannas, especially places like the Cerrado of South America, which is a mega diverse region, but people thought that it's just a degraded forest. So it does clearly apply to a lot of other places, especially in the tropics.
Oh, sorry, I guess I have some network problem.
Okay, should
Yeah.
I repeat the thing or
Yeah.
should I repeat it?
Yeah, maybe that last
Okay,
one.
yeah. So I guess it's pretty common that people have misinterpreted tropical savannas to be forest degraded forests is what I was saying. So it's not just India, it's not just some countries, it's clearly most of the tropics actually. So it does apply to a lot of other places.
Okay, thank you.
Does anyone have any other question? Oh, there is one on the chat. That was a fantastic presentation. Ashish, what are your recommendations as far as land management goes? Not just in the ecological sense, but in a broader societal setting.
Right. That's a really nice question. So ecologically, it's pretty meaningless to add trees, but in the sense of uh, society, in the sense that these savannas are located in a city, it's pretty tough to handle this thing because we have been brought up with this notion that trees are good, planting trees is beneficial for so many things. And what needs to be done is actually trying to demystify this thing that trees everywhere are good. So it starts with education early on, is what I think. And uh, appreciating savannas in an urban setting is critical because these are the places where you have most of your decision makers. So if you convince decision makers in your city that, hey, see, those hills, they're really ancient, you can probably convince them to save other places which are not so accessible to people as well. So that's my take on it.
If you have any follow-up questions, look, you can unmute yourself so you can keep talking to Ashish. Does anyone have any other question?
I have one more question.
Yeah, sure.
Yeah. So, do you think many of those species which lived like maybe which were there in the region some several years ago would be suitable to grow now with the current climatic conditions? Because the climate has also changed with the due course of time over the millions of years.
Well, what we see is the species which have gone locally extinct are the ones which were savanna endemics or savanna open canopy species in terms of plants typically. So I wouldn't say the climatic fluctuations have been that severe that it would hamper restoring them back. Again, it's a huge challenge to restore savannas back. So it's an entirely another issue that if or how should we go about restoring things which are converted into plantations right now. So that's an entire ballgame.
Okay. But given the scenario, if I want to preserve the existing extant species which are still
Mm-hmm.
there, so
Mm-hmm.
what would you go forward? So do you think like you just keep it the same way, protect?
No, actually, the thing is, right now, throughout other places in the tropics as well, fires are seen as detrimental for the biodiversity. So it's a huge task to make people aware that not all fires are bad and that fires have been important at least since 4 million years in shaping these landscapes and the biota. So the moment you stop fires, which is happening everywhere in the world right now, you automatically lose out on those endemic species. So there's a lot of things we can do proactively. Also, because this is an urban setting, you can have a lot of um, flagship species for the regions and trying to tell people stories using those species and how their habitats were before, what they need, so on.
Okay, thank you.
So, yeah.